Good morning, good afternoon, and good evening to our viewers from Fiji to Turkey in the Asia Pacific region and beyond. My name is Jose, and I'd like to thank you all for joining us today for this productivity talk organized by the Asian Productivity Organization. Today's P Talk is the circular economy in action. The world's population is projected to reach 8.5 billion in 2030. As a result, the demand for all types of material is expected to grow, especially in meeting the needs of us human beings. Consequently, the amount of waste is also expected to increase, and environmental problems such as climate change are expected to become more serious. However, some waste still has much to offer under the circular economy model in terms of potential benefits for business and society, while protecting the planet for the future generations. The conventional linear economic model of mass production, mass consumption, and mass disposal can no longer be sustained globally. We need to balance development and growth with the environment. Today, we have an opportunity to explore this topic and understand how the circular economy could benefit humans and our global environment and its link to the green productivity of the APO. Joining us in this P-Talk is Dr. Shun Fung Chiu, or as I fondly call him, Sir Anthony. Sir Anthony, would you like to say hello to our viewers, sir?
Hi, good afternoon to all the viewers and colleagues of APO. Thanks very much for inviting me to this APO event.
Sir Anthony is a specialist in industrial engineering, resource efficient, cleaner production, sustainable consumption and production, and eco-industrial development. He is currently a university fellow and professor at the Salle University in the Philippines. Sir Anthony is a Philippine delegate to the UN ESCAP roadmap for the 2030 agenda, as well as the Rio 20 Summit, Commission on Sustainable Development, the UNCRD 3R Forum, among others. Sir Anthony also serves several international professional entities and is in fact an editor-in-chief of the Elsevier journal Cleaner and Responsible Production. So Sir Anthony, welcome again to our P-Talk today, and we hope to hear more about your insights on circular economy in action. And to our viewers, we encourage you to send your questions or comments on the topic in the chat box for the Q&A session later. Since we are all live, so we have an opportunity to directly ask Sir Anthony on the topic or the questions that you want to raise on the topic. So now I would like to invite Sir Anthony to give his presentation.
Thank you very much, Sir Jose. Let me enlarge this screen myself at my end. Okay, good afternoon again to all colleagues. So my talk this afternoon is on this entitled Circular Economy in Action. Circular economy can be discussed in very broad sense. No? It can be discussed from an economical point of view and many other dimensions. What I will focus more today is more on resource use, especially from Asian productivity point of view, and also comparing to what we have been doing in Asia or something we have originated in Asia already in the past 20 to 40 years of efforts in this work, especially through the good coordination of the APO. You may be very much familiar with the Ellen MacArthur Foundation Circular Economy butterfly diagram like this. On the right side and the left side, you have the organic and the inorganic or the industrial opportunities of circularity and circulation of the different resources so that they will be brought back to the value chain again. However, I would like to stress that for a long time, we have been doing and working on this from a research framework point of view, being an industrial engineer and also an industrial ecologist. What is an industrial ecology? Industrial ecology, we work on the balancing and harmonization between the ecosystem and the industrial activities. Over since the time of industrial revolution, industrial engineer has been tasked to convert or to transform all the resources into goods and services in order to serve the humankind's demand. However, over these years, we have been able to efficiently carry out many theories and many concepts, especially with the introduction of mass production, as we are very much aware of. So we started with the mass production or the mass customization that was evolved, and it leads to a mass consumption and mass disposal, and this we call a linear flow. And this is already patterned as a unsustainable consumption and production pattern, meaning that we have been extracting more, thinking that the planet is having unlimited resources, which is not true. And also we are disposing more than the carrying capacity, or we, in layman term, the digestion system, or the capacity or the factory capacity of this planet. So these are very much simple words that we in the industrial engineering or productivity community are familiar with. So the industrial ecology, through the early book of 1990, written by Tom Gradle and Allenby, have already traced the pattern of the resource flow. I will not show the first slide, which the first leftmost, which we already know. We think that we have unlimited resources, so our job of industrial engineer or productivity community is to transform them as efficiently as possible, but that is not sustainable. Currently, we are in the stage of recycling part of them, keeping and maintaining them in our human economic system as long as possible, so that we prolong its value in the system and limit the flow of enormous waste to the ecosystem that may go beyond the carrying capacity of our planet. Of course, this is still not sustainable. What is a sustainable one is on the rightmost side, which we think that only the photosynthesis through the solar energy that's coming in, which is limited, so well, in terms of time, and it is renewable, of course, the solar energy. But we would love to have everything in the closed loop. But of course, do we have the technology to do that? That is still a question. So we are still staying right now in the second stage, which is the partial closing the loop. Therefore, in a practical sense, a system engineer, industrial engineer's task is to close the loop of most of our consumption and production system, because consumption can also be interpreted as the consumption of raw material by the producers, plus also the consumer, who are the end products and services. But everything is a one big loop. And if we can close that loop as much as possible, then we have a full or nearly a full circularity. And that will really be more sustainable than the linear flow. In reality, tracing back to the Asia Pacific economies, as early as year 2000, Japan already introduced the recycling-oriented economic society law, or you may be more familiar with the sound material cycle society law of 2000. Now, it has been very much encouraged by the trade and industry, and also the MOEJ. And of course, one of the biggest and most successful examples that the entire region is aware of is called the eco-town. And some of the popular eco-towns are the Kitakyushu eco-town, the Kawasaki eco-town, and others. And one of or two of them will be discussed in brief later. Following the 2000 sound material cycle society law, China also enacted a circular economy promotion law following the cleaner production promotion law in 2008. And they have a newer version, if I'm not mistaken, in the 2018. So actually, we have some documents to follow in order to do circular economy in Asia among our economies. However, I would like to say that the 2000 the year 2000 economic society, recycling oriented economic society law of Japan do have a very interesting framework, and it is very, very useful. If you recall that we have the linear flow a while ago, that means that we are extracting everything from the bottom, which is the natural ecosystem, all the raw material, and bring it up and to be transform them into product and service. Now, of course, the consumer, from an economics point of view, the consumers, they will be served, or they will be consumed by the society at its highest value, or the highest willingness to pay in the economic sense. Therefore, at the tip of this dark line, from the arrow extracting all the raw material from the ecosystem at the bottom, then all the resources were consumed and sold to the society. That is the highest point. So this diagram shows us a XY axis. So vertically, if it goes up, meaning that the value has been increased. And the higher it goes, okay, the higher the value is, until at the peak, it is being served to the human, or to the society. So we can see, while it goes up, it may be go through the conversion from very much metal ore into metal sheet, and then from the metal sheet it goes into the production into a automobile, which we are using today. Either it is gasoline engine, or it is already an electric vehicle, or we are going to expect a hydrogen cell a vehicle very soon. It also depends very much on the design. So the design will also determine how much energy it will use while during its consumption, and also the design of the production process, so that if the production process can be cleaner, that's why we can avoid the production or the generation of pollution during the production stage. But pollution is not happening only at the production stage. If you will go to the right-hand side of the dark line, or of this circular line, then when we finish the consumption, or we call this end of the life of the product, and if it is not reused, if it is not recycled, or it is not refurbished or manufactured, then it will go down directly to the natural environment again. This is a direct disposal. In some countries, there is no recycling facilities, then that's what it will happen. But in other countries, we will see there is a full package of recycling. Now, there are three terms we introduced in the early 2000s about recycling. One is upcycle, one is equicycle, and other one is downcycle. And most of the recycling activities we saw today are downcycling, meaning that 1 ton or 1 kilogram of original product, after recycling, the value goes down in its new form. Well, we can take a look at PET bottle as one example. If PET bottle is transformed into eco bag, then the value per kilo will be lower. However, if we can convert it to the same value, we call it the equicycle. In Kitakyushu, they can convert all the glasses or the light bulb fluorescent glasses back to glasses again. Then that is an equicycle, meaning that you transform the resources back to its original form, or the same similar form, so that the value is the same. And of course, the better thing is upcycle, if you can transfer something of higher value after the cycling or recycling activity or technology. Now, equicycle may sound good because you are transforming something after the end of its life back to its similar form. However, we are not only dealing with the value of the resources itself, we are also dealing with, we need to input the 4M. Okay, we need also capital investment. We have human capital that goes into the entire process. So who's going to subsidize that? And the government cannot forever subsidize. Therefore, it is an important economic strategy that we need to look for upcycling strategies and technology. Now, after recycling, this beautiful picture also shows us a very important thing. How do we do all this recycling if they are not collected? Therefore, the introduction of extended producer responsibility is also included in this entire framework. After the introduction of from Thomas Lindquist from IIIEE of Lund University, the concept of extended producer responsibility in Japan, they have early in 2000s already introduced how all these recyclable materials would be collected and who can reassemble or disassemble and reassemble them in the best manner. Therefore, companies or factories who produce them put together a disassembly plan so that they will be the best, have the best knowledge to disassemble them. And how to disassemble them, maybe the highest value parts will go in last in the assembly so that during the disassembly, we can take out the highest value part first. And therefore, we will find a break-even point wherein we do not continue doing the disassemble because of the high labor costs or because of the many other factors. Now, that is one factor explaining how come full or 100% circularity may not be economical at some point. It really depends on the infrastructure, the technological know-how, and the human behavior. Let's go to the next one. We talked about clean circularity or the circular economy model earlier, but is it really the end objective? Of course not. What is the end objective? The end objective is the decoupling, meaning that the end objective is something that will bring us to a sustainable development. Sustainable development is talking about the balance of the three bottom line, the economic bottom line, the ecological, and the social well-being. And in order to achieve that, so far in 2011, United Nations International Resource Panel has introduced the decoupling technical report, and it has clearly defined that our economic growth should not rely too much on the resource consumption and should not generate too much negative environmental impact. They must be decoupled. And how can we do that? Of course, there are many ways of doing that. Green productivity is a very important tool. Green productivity at a factory and at a facility level, we can prevent the generation of pollution, and therefore, with the reuse of many other resources such as water, so the equal amount of water can be reused several times. Therefore, the resource use is no longer proportional to the economic gain. And therefore, we use less and we produce higher economic gain. That is what is needed in this society. We need to continue to gain economically, but we need to delink the resource use from the economic activities, as well as to reduce, if not totally zero, the negative environmental impact through eco-design, which we have now the life cycle assessment toolbox and many other toolbox to improve our eco-design of products. So this economic model or decoupling framework is the important concept we need to follow. And circular economy at this moment is one of the good tools to achieve that. Why circular economy? Because circular economy goes beyond the wall of the facilities and a factory, which we will discuss in the next 10 minutes. So coming back to our green productivity, we use a very important system thinking, because in order to operationalize circular economy, operationalize the decoupling, we need to have a complete system thinking. There are many things that will be escaping from our framework or from our window if we do not have capture all of the elements properly. Example in the pollution. If we handle the wastewater and transform them into sludge, we are converting liquid waste into solid waste. And if the sludge is being incinerated in most economies, they become a gaseous waste. Therefore, it's escaping from one form to another. Unless we use a complete system thinking, we will not be able to solve integratedly the entire issue. And therefore, we have the input, the throughput, the output, and the roundput here, so that we will be able to identify what are the strategies and opportunities we can put into the entire system and make it a sustainable pattern. On the input side, if we do not need that much raw material, we should conserve them. And this is the concept of sufficiency in many economies, especially one of the members of APO, Thailand, has been promoting sufficiency concept for many, many decades. And for the throughput, we want to achieve resource efficiency, especially in terms of producing or converting more raw material into product and generating zero byproduct or waste as much as possible. And by doing so, we will be able to avoid and prevent pollution through design, through process engineering, and we can also improve the environmental health and human health that directly improve also the well-being. Now, in order to further operationalize it, we all understand, most of us doing the green productivity in a single factory or a single facility, it is quite challenging to reach a zero waste level. Therefore, there have been over the years, from 1995, since I have been involved in this work, we have been looking into other opportunities, like, for example, through the value chain or the supply chain, through the entire life cycle management, and then move on further to industrial symbiosis. Now, in the industrial symbiosis, we are thinking that the waste of one industry at a certain stage of their supply chain may be used as a raw material, as a input to another industry chain, and that is the rightmost picture you have seen in this diagram. And one of the earliest introduction or documented example or case in action happened in Kalumpur. We have been doing this back in 1995, 1997. We got these documents through the UN environment, and Francis and also the colleague from Switzerland, they documented them further. They capture the flow over various entities in the same community in the resource flow in terms of waste, sharing the waste and exchanging the waste, so that waste of one become an input to another, or after processing become a substitute of raw material to another one. And also the flow of the water, which is easily monitored if the amount, the quantity, the temperature, and the degree of its BOD, COD level is still acceptable for the next process. And of course, the cascading of the energy through heat exchanger and many other equipments in the mechanical engineering settings. And we have transferred these ideas to Asia Pacific back in 1997. And in year 1998 to 2001, drastic involvement of green productivity in industrial park have been promoted. And we have conducted such training workshop in Manila and in many other economies about green productivity extended to a bigger system boundary wherein different entities can share resources, can design the process together, can design the system together, including logistic delivery. And for Korea, they have already involved several industrial parks at that time, so that they will be able together to reduce the waste theoretically to zero and the manufacture output or GDP to its maximum, while not emitting any toxic waste or harm to the environment. Therefore, they receive the highest social image. So this picture shows us how many economies in Asia Pacific have been involved since 1997. Japan has its eco-town, Korea has its eco-industrial park, Vietnam, China, India, Sri Lanka, Thailand, all have its initiative. Now, this is not just applicable to industrial town or industrial park. It can be done city to city or even at the national level, as long as the flow of resources are properly studied. And in order to do that from step to step, I also introduced in the 2001 APO training kit on how individual factory can do green productivity, how it helped its supply chain within the industrial park, how it helped more standalone in entities within the industrial park so that the facility can be shared, can be all collectively developed. And finally, this facility can also benefit entities such as even the rural or the urban community outside the system boundary. A system boundary, again, as I said, can be an industrial park because it has a certain wall, or it can be a cluster of communities. Early cases, one of them, of course, is the Hibiki in, SMEs in Kitakyushu, that they have different factories that can focus on different processes. One can process the fluorescent lamp, one can process the PET bottle into refuse-derived fuel, one is also using plastics, etc. And they are not only processing the waste generated within the industrial zone or the ecotown, but they are bringing in the resources, the waste from the region of its vicinity. Now, why vicinity? Because proximity is an important issue here. Carrying and delivering and bringing in the material into another area is also consumption of energy, fuel, and human resources. Therefore, there is a need to trade off and balance these things. So maybe one ecotown may focus on 5 items and another ecotown can focus on another 5 items. Therefore, there is also a plan of integrating various ecotown effort together in the Tokyo Bay. And the same case is happening in Korea. This is the example of Ulsan, wherein the different big companies, SK, LG, and Hyundai are working together. Now, in this case, we have studied on the legal issue on how companies can go into contract, long-term, short-term, mid-term, so that a resources can be guaranteed. And of course, the different industrial zone in the different area can also support each other. After doing an industrial zone or in a cities, actually, it is very important to look at the bigger picture. And the last 3 minutes, I would like to discuss this bigger picture using material flow accounting. This is called economy-wide material flow accounting, so that we will be able to see all the resources going in and out. And this is published in Nature a few years ago, and a study of one of the easiest to recycle material, which is aluminum. Because we know if we will convert everything from bauxite to an aluminum product, the energy is enormous. So it is the best to recycle those existing, we call urban mining. And with that effort, we can see that even in efficient economies such as Japan, Switzerland, and Australia, the amount of recycling rate for the entire economy is still insignificant. This is the small line that you see that is being recycled. Still a big part go to the solid and liquid waste. Still a big volume goes to the air emission. It means that complete circular economy takes in or requires a lot of effort, a lot of parameters, a lot of discipline, a lot of infrastructure, technology, and human behavior. And for this, we have discussed last year in November, in 2020, 2 years ago, 2022 in November in Paris, where in the European Union reflected to us that in the European Union, the recycling rate is still not satisfactory. And some of the challenges, like the technological solution is available, but it is not taken by the market. Why? Why is the market not accepting or implementing this technology? And they're also looking into the young generation, how the young generation utilizing all these new intervention to encourage the business of circularity in the at the global level. So we will love to hear more from the comments of the audience. And I just came back from the United Nations Environment Assembly in Nairobi, and we have been also encouraging and promoting circularity through decoupling as the goal. We wish that uh, more and more resources will be able to be kept in the economy and reused at a higher value. Thank you very much for listening.
Thank you very much, Sir
Yes,
Anthony,
sir,
for
Jose.
Thank you very much, Sir Anthony, for sharing to us your knowledge on the circular economy. It's very interesting to note that this is a kind of a global phenomenon and a global knowledge, and yeah, and giving us some examples of countries, especially in the region. You cited a good example in Japan, in Korea, and they are now elsewhere implemented in countries like Sri Lanka, Thailand, and many more, especially in the region. So, sir, I'd like to bring our discussion to, I would say, in a personal point of view. So, like as a consumer, as an individual, as a citizen, and as a small company. I think your examples for example, earlier, especially in Korea, there are quite big companies, conglomerates in the country. But let me start my question. And of course, I encourage our viewers also to send your questions here for Sir Anthony to answer. We are live now, by the way. So hopefully we'll have your questions. So, sir, let me ask you first my question before I will read the questions from viewers. So, sir, so for the consumers, for example, can we expect changes in consumer behavior with the adoption of the circular economy model? So what you have presented to us is more on the company level. But what about the consumer? What kind of behavioral change will take place when we adopt circular economy?
Thank you very much. Consumer, if they are given the choice, and if they have the so-called green consumerism, or we should also use the term sustainable consumerism, which is the correct term, then there would be a very good direction that we can move into a better world. Why? Because consumer will be able to choose the, for example, energy in terms of electricity supply at home. If they have a choice of choosing or buying or installing renewable energy source that they can use, like solar panel, like electricity generated from the windmill or wind technology, uh, and moving away from the fossil fuel fired oil fired power plant. Now, if they do not have the choice, that is the next issue. We also make a study in Japan wherein the big supermarket actually has a very influential uh, power, because in for many years we believe that the consumer can give a tremendous pressure on the producer to produce something more eco-design, because there is such a consumerism towards sustainability and demand. However, if the medium, which is the big supermarket, will be able to do a choice editing. This is another important strategy, meaning that they only provide products that are greener, because there is no such thing as absolutely green. So if there are two products, they will only patronize the greener product and put them on the shelf. So that is a we call choice editing. Now, over many years, many economies in Asia have already gone into bilateral agreement on eco-label. So eco-label product adds on to the choices of the consumer. However, eco-label product has been more expensive. And Japan, being a leading promoting country through the IGPN, they have been promoting public procurement that go for after green product, meaning that if the government and the state enterprises, they are the big consumer, and they can patronize more the green label or eco label product, the demand for the green eco label product will move up. And if the volume is or the demand goes up, then the cost of production will go down. Therefore, it will bring the competitiveness between eco label product and the most commodity, and offering them to the consumer at a reasonable price. That is always the challenge. Consumer is willing to buy, but if the price difference is high, then they may not really land on the more greener product in reality.
Yeah, thank you, sir. If I quote the last part, actually, earlier when you're explaining, I was thinking, does it mean that the cost will eventually, because there will be an added cost when we, especially when we start to adapt. So I was thinking, does it mean that it will immediately be, say, top up to the price, and eventually consumer will pay for the price? But thank you that the economy
If
of
we are
scale
willing to pay,
will
but
be
I think
applied.
there's a smaller percentage. Yeah.
Yes. So, sir, let me. I think we have a question here from our chat box from Amit Kumar. So, let me read this question. Thank you for your presentation. And my question is, how can AI and emerging technologies be harnessed to optimize resource utilization, enhance waste management systems, and drive innovation in the circular economy?
Okay. My best regards to Mr. Amit Kumar, also my colleague from AIT. And yes, we have already seen the effect of AI in our daily life, and they have actually mobilized the big data and be able to utilize these data. As I said earlier, it is like the system thinking. In the early days, we have only limited information of data and information in a small part of the system. And therefore, when we make a decision, the decision is really called a local minima. Nowadays, with the AI and with the big data, with the data security, which is blockchain, okay, this, if properly utilized, will be able to come up with a faster decision making that is more optimal. However, the government should be able um, to monitor and also to provide and make this data available, because all the data we know, if it is a trash in data, it can be a trash out decision. So the data quality is very important here, and we have been spending a lot of time dealing with the data. Also, another big challenge here is AI is just a piece of well, it's just like a knife of or a blade of two sides. It can be used also in marketing, where in marketing management in the early days says that if there is a demand from the market, provide the demand. But if there's no demand from the market, you have to generate the demand, and that also initiate more and more extraction of resources to fulfill the increased demand. So therefore, if the AI, okay, is improperly used for marketing purposes and for improper, unsustainable consumption purposes, it may also give a negative impact. That is the reason why when we did a study for the Asia Pacific over the last 50-year data, it shows that we call it the IPAT. The impact is relevant to the population growth, to the affluence or per capita consumption, and the technology. We are believing that the technology should provide better management of resources and therefore bring down the stress on the environment, on the human health, on the ecosystem health. Unfortunately, it is not. Because of the technological availability, there seems that in Asia Pacific, there's an increased impact, such as convenience. With the mobile phone, we can order a single cup of coffee easily through the apps, and there is an increased number of demand of products, and this kind of advertisement and marketing has been attracting consumers from all directions. That's why it is also very important that we have the upright, important human behavior, consumer behavior towards sustainability. Thank you.
Thank you, sir. Thank you very much for the question, Mr. Kumar. You can have a follow-up question. I think Sir Anthony gave some examples, and if you have follow-up question, you may do so. So, sir, I would like to continue asking question from our viewers. So we have question here from Maria Asuncion Quinto. What is the criteria, or what are the criteria for green products in the field of agriculture? I think circular economy cut across different sectors. So in the field of agriculture, how can we go greener?
Thank you for the question. There is actually a community of agricultural scientists working on green product, and I believe that they are meeting every year, every 2 years in Thailand, under the Salle University. The general toolbox that that is available nowadays for the scientific community is called the life cycle assessment. It can be done from a cradle to grave. So meaning that we start with all the resources, started from the extraction until the different scenario where end of life of this product is being disposed. So different way of disposing them will also generate different kind of impact. And therefore that will generate a certain kind of figure or number for a resultant number for that product or through that technology in the consumption arena. Now, then when we compare two similar product using different pattern of production or similar different pattern of disposal, then we would be able to compare which way it is produced is more or is less impact on environment. Every human activity will generate an impact on environment. There is no such thing, almost no such thing as in human activity will benefit the ecosystem health because of natural law of entropy in thermodynamics. Therefore, coming back here, the LCA assessment number or the figure that we computed will give you this comparison. However, I'm not so sure if I believe Ms. Asuncion Quinto is from the Philippines. So each country has a eco-label scheme, and in the Philippines it has a eco-label scheme. I'm not so sure if many agricultural product is already included. There will be a committee working together between the eco-label coordinator, DNR, and the DTI. This is the Ministry of Environment and the Ministry of Trade and Industry, ruling on the criteria. And then there will be a technical panel also checking on the LCA values that are being computed. So every product that would like to get an eco-label should submit all this computation. Now, we have evolved now to ESG. And we also know that in ESG, there are also natural easier way of computing simple impact, because LCA will generate value for different impact on acidification, eutrophication, on carbon or climate change using the carbon equivalence, and etc. But usually nowadays, many people would like to focus only on carbon. So therefore, you can only work on single parameter, which is carbon footprint. Or some people would like to look into water, including the virtual water that is embedded into the product. So you have water footprint. So these are single parameter computation that you can do. Is there a software? Yes, there are web-based free software for life cycle. You can also get a free software called SEMA Pro and many others free software as long as used for educational purposes. Thank you.
Thank you, sir. Thank you very much, sir. So a follow-up question to that. So you mentioned some examples, and even your presentation, you mentioned like this eco-label, eco-design. So these are basically captured in the circular economy when we talk about this labeling. So basically, they are captured in the circular economy model.
Eco-labeling normally is a important tool for number one, eco-design, so that we will be able to compare if the new model or the new design is better than the old one. If we are comparing our own product, like air conditioning, they are always having these energy factors. Another one is eco-labeling is very useful in public procurement, so that I think there is a green product handbook kind of published also by a Japanese IGPN and kind of association in the promotion of green public procurement.
Yes. Okay. Thank you, sir. Thank you, sir. So thank you for answering that follow-up question. So I'd like to ask another question, this time from Malaysia. Dr. Ida Yassin, I know her personally. My question is based on your experience. What is the biggest challenge for companies to adopt circular economy in their business?
Okay. This is very this is a very interesting question because companies, depending big or small. Okay. Now let us talk about SME first, small and medium-sized enterprises, because most of the companies in Asia Pacific are SMEs, if not MSME. Now
Yes.
SMEs, for us to improve the product design, okay, we can do that through individual effort or through group effort in product redesigning, and therefore this is done mostly on desktop and prototyping. And therefore we will be able to produce a product that is designed for disassembly or designed for recyclability or designed for sustainability. So these are all the different approach of eco-design of product. And this can be done, as I said, easier because nowadays we have all this computer and we call it the 3D prototyping or 3D printing. Now, the re-engineering part, which is the green productivity training, the green productivity training that takes about 5 to 7 days for people to look into the different ways of analyzing where the waste is coming from, how to avoid the waste, how to use the raw material more efficiently so that product will be more in terms of GDP generation. So for small and medium enterprises, they may have limited resources. And for that reason, if they are belonging to a similar sectoral organization or they belong geographically to a industrial zone so that they are part of a certain tenant association, or we call it the locator association, then they can group themselves together for training. And they may even have common facility that can be shared to treat some of their we don't call them waste, but pretreatment, so that it will be producing less impact. In order to bring down the waste to minimum or to have all the parts to be recycled modular, okay, it is also doable, but it really depends from product to product. So that is the usual case for a challenge for the SME. For the big companies, since they are a conglomerate, they can also work easily with the supplier and the buyer. So all together, they can do this kind of a value chain or supply chain industrial symbiosis, because there is already a trust developed between the supplier and the buyer of this big conglomerate. So those are the challenges, and also we call it the early approaches that they can use in the different levels or groups or sizes of the companies in the private industry. ESG has also many new approaches, but most of these approaches are leading to use of clean energy, renewable energy. Again, this infrastructure and this provision also depends on the availability from a macro environment, from the government or from the local facility. So sometimes it is not easily determined by a single facility or single company. Thank you.
Thank you, sir. We're waiting for more questions from our viewers, but I'd like to connect my question now to what you have just explained. I'm not sure whether it has been answered, but I just want to make it clear. So for SME, for example, if they adapt to the circular economy model, what and where are the expected changes? I mean, where would they start?
Where will they start? Of course,
Yes.
with the product that they are with the product that they are offering, and also with the process that they are undergoing. Now, the first thing is, what is the driving force? Why will they be doing it? Okay, first of all, if it is out of personal individual willingness, or in the government we call it the political will. So if there is a will from the owner of a small and medium enterprise, in which I know many of them. I was just approached by my former student who graduated more than 10 years ago and started telling me yesterday about what initiative he has been doing in the last 10 years, because he attended he was so much persuaded that individuals should contribute. However, some of the main driving forces are supply chain influences. So if SME are supplying their product to a bigger company, and the bigger company are exporting to other continents, usually there are these, like for example, European Union directive expecting or regulating certain percentage or certain practices. And therefore, this kind of regulation will be cascaded to the exporter, and the exporter, which is the big company, will cascade it also to the smaller and medium enterprises. And therefore, sometimes if they have this kind of supply chain relationship, the big brother, small brother approach will be implemented. So the big company or the exporter will be providing support and assistance, including technical know-how, to the SMEs, so that the contract between the two entities will continue as a supply chain for their exportation. That is one important scenario. There are also scenarios wherein small and medium enterprises do not have this supply chain relationship. So where is the driving force for this SME to do cleaner and greener productivity? Then we also look at many other restrictions. So we have local government regulations, we have national government regulations, and when the agencies are doing regular inspection, then there is also a natural environment that they need to comply with the local law. And of course, that is the basic knowledge we all have when we are giving this green productivity training workshop, including doing ISO 14000. The basic thing is that compliance with the local regulations. Thank you.
Thank you, sir. Yeah, I understood well, and I'd like to pick up your last two lines about these regulations and compliance. So before I ask someone's question in the chat box, so I want to connect my question now to this. So will there be more regulations if we adopt the circular economy model? So I think SMEs, companies, or the private sector are already burdened with all these regulations to protect the environment. And now with this circular economy model, will there be more regulations coming into play to make sure the compliance? I think that's how, I mean, your last three statements explain that way.
The circularity will bring more stringent practices, but it should also bring us benefits,
Okay.
because these are also business opportunities. In the circularity or the circular economy, there will be new business opportunity that will arise, wherein there will be entry of new players in that business business circle. Uh, what we will also expect to see is that there are some urgent issues that need circularity to take place. We want to highlight the single-use plastic uh, in the marine littering dilemma. And because of that, many economies are now working towards extended producer responsibility. And therefore, meaning that companies that are producing single-use plastic, it's either being banned, or the demand will be reduced, or you have the responsibility to take back all these um, products that were delivered to the economy. And because of that, there will be a trend of looking into replacement, because byproduct that have a very low economic value will require much more effort to have the collection process. And if there is no subsidy from the government and everything will go to the producer who produces that, then eventually the producer will stop producing that kind of product because it will be no longer profitable, not even break even for them to do all these um, businesses economically sound. So it is very important that we have more opportunities than the constraint is presented to the companies. Government should be able um, to 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 distribute the wealth equally, especially to the sector that contribute much to the circular economy in this arena. We understood that there are some economy has stopped and banned the importation of certain byproduct, and therefore this byproduct has been flowing to many other ASEAN countries, including Malaysia, plastic byproducts, and there is a generation of increase of these economic activities in these countries. We are very quite we do have a record and data about that. So there are equal benefits and constraints.
Thank you, sir. Thank you very much. I think the key point to my question is that there is opportunity in the circular economy model. So, sir, we have one question here. I think the question relates to one of your slides where you talk about the conceptual diagram of a recycling-oriented economy, where you put this down cycle, equi-cycle, and up cycle. So the question from Ms. Santi Setiawati here is that how can policymakers contribute to enhancing demand for upcycled products in society?
Upcycling product is well, it sounds good because after the recycling activity, the value is higher than its original product. That is the first thing. And usually this require a very special technology, and it is that is why most of the product after recycling do not go upcycle. It normally go equi-cycle, which is already very challenging, and most of the time it goes down cycle. So how can government promote that? Of course, it is a big investment. uh, First of all, you should have the capacity to do so. So especially for Asia Pacific countries, we should have a very strong R&D capacity that requires National Academy of Science that can provide research for indigenous technology, because many of these product that may be able to get upcycled are indigenous product, and base technology may not be available just for a technology know-how transfer, and it require an indigenous research. So many of them require a local research laboratory, local research capacity to do so. So countries that have do not have a strong R&D force may not be able to capture this opportunity. Therefore, most of the recyclable material are suggested to be uh, done at reuse and reduce and reuse process. So meaning that we want to do have reuse or modular design so that part of them can be repaired and used again at the same level instead of recycle means that uh, it is already at its end of life, and then we try to process them into a certain raw material and use it again for use for production of of another product, which is much more energy. If you will look at the butterfly diagram of Ellen MacArthur, that is the farthest among the three R: reduce, reuse, and recycle. So let us focus first if we can reduce the use or we can reuse it. Reuse has many modes. You can repair, refabricate, uh, 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 refurnish, or we can even have a modular design so that same product will be functional again, instead of going through the entire process of recycling. So, in short, R&D capacity is very important if we want to do upcycling concept.
Thank you very much, Sir Anthony. I think time flies. It's like almost 1 hour already has already passed. But sir, let me just ask this last question. Maybe this is to leave a message, especially to the government, because I understand that the government plays a very important role. In our earlier question and answer, we talk about regulations and compliance, and this is basically the role of the government. So your message to government will be. What should they do to promote the circular economy? We have seen the benefits, the opportunities, but I think they play a very important role so that this circular economy will push through and we all reap the benefit of this model.
uh, from the word alone, circular economy is not just about resources, but it's about economy. So the government should not look at it as an environmental strategy. It should look at it as a socio-economic and environmental or sustainable development strategy. Usually, government agency should have an umbrella role, like the National Economic Development Agency, so that they will be able to see the whole picture and see what are the different entry point where resources, reused resources, circulated resources can go into the system and provide new opportunity for businesses to boom. So, and also to reduce the impact on existing industry. So these are all important areas that the government should look at, and they should have the correct and available data to handle all these issues. Thank you.
Thank you very much, sir. So I hope our representatives from the public sector or government, especially those in the with the function of regulation related to the environment, environmental protection, climate change, I think you will be able to catch something from the last message of Sir Anthony. So I would like to end this conversation with Sir Anthony with this message that the circular economy is not only about recycling. I think he emphasized that in his just answer to my question now. It is based on some principles like eliminating waste and pollution, circulating products and materials at the highest value, and regenerate nature. If our business model is anchored on this circular economy paradigm, as explained by Sir Anthony in his presentation earlier, then we all become its champions in propagating the model across different economic sectors and linking it with green productivity of the Asian Productivity Organization. And I think Sir Anthony gave a very good explanation on how this circular economy is highly linked to the green productivity model of the APO. So we thank Sir Anthony for sharing his insights on the topic, the circular economy in action, and he gave us some examples from the APO member economies. Now I would like to ask him for his final message.
Uh, Again, triple bottom line: economic, ecology, and social well-being should all be considered in circular economy. So there is win-win-win in this strategy. Thank you.
Thank you very much, Sir Anthony, for a very inspiring final word. And we also thank our viewers and hope that this speed talk will contribute to efforts to understand the circular economy in action and how it impacts in pursuing the balance of development and growth and environment. We also thank our viewers for joining us today, especially those who have raised questions. We truly appreciate your continued viewing of this program. So please stay tuned in our forthcoming P Talks to learn about different topics that affects the productivity of individuals, organizations, and economies as a whole. So with that, thank you very much again, and please stay safe and goodbye for now. Thank you very much, Sir
Thank
Anthony.
you. Thank you very much.